Today we are going to discuss variation of variation of of various physical quantities on of capacitor on insertion of dielectric। तो आज हम लोग क्या बात करने वाले हैं? हम लोग बात करने वाले हैं कि कैसे डिफरेंट फिजिकल क्वांटिटीज रिलेटेड विद कैपेसिटर्स चेंज होती हैं, वैरी करती हैं जब उनके प्लेट्स के बीच में हम लोग किसी भी तरह का डाइलेक्ट्रिक को इंसर्ट कर देते हैं। तो लेट अस कंसीडर अ कैपेसिटर, और इस कैपेसिटर के let us consider a capacitor, parallel plate capacitor whose capacitance is C। तो C क्या है बच्चों? इसका कैपेसिटेंस है, या C नॉट इसका कैपेसिटेंस है। कैपेसिटेंस ऑफ द कैपेसिटर। इस कैपेसिटर के प्लेट्स के बीच में इसका जो एरिया है वो A है। A is the area of the plates of the capacitor। D जो है इन दोनों प्लेट्स के बीच का डिस्टेंस है। D distance between the plates of capacitor, distance between the plates of capacitor। तो जब अभी इस दोनों प्लेट्स के बीच में जो डाइलेक्ट्रिक फील्ड है, जो इंसुलेटिंग मटेरियल फील्ड है, वो इंसुलेटिंग मीडियम जो है वो एयर का है। तो ऐसी सिचुएशन में इसका जो कैपेसिटेंस है C नॉट, उसको हम लोग लिखते हैं एप्सिलॉन नॉट A/D। इसमें एप्सिलॉन नॉट क्या था? ये था परमिटिविटी ऑफ एयर और वैक्यूम। अब जो हम लोग बात करने जा रहे हैं कि व्हाट वुड हैपन इफ द प्लेट्स, if the insulating medium in between the two plates is replaced from air by some other dielectric material। तो अगर मैं इन दोनों प्लेट्स के बीच का जो इंसुलेटिंग मीडियम है, अगर मैं उसको रिप्लेस कर दूं, किससे रिप्लेस कर दूं? एयर से रिप्लेस करके कोई दूसरा डाइलेक्ट्रिक मीडियम डाल दूं, तो व्हाट वुड बी द न्यू कैपेसिटेंस and what will be the changes experienced by other factors that we have got। this is what is the agenda for today's topic। तो अगर मैं यहाँ पर इस पूरे प्लेट्स के बीच में जो कुछ भी जगह है, इस जगह को कंप्लीटली फिल कर दूं किसी और मीडियम से, तो इस मीडियम से फिल करने पर इसके कैपेसिटेंस के ऊपर क्या फर्क पड़ेगा, क्या चेंजेस आएंगे। दिस इज व्हाट वी आर अबाउट टू टॉक। सो अर्लियर क्या था? जब एयर फील्ड थी तो एयर फील्ड कैपेसिटर क्या कैपेसिटेंस निकल के आया था? एप्सिलॉन नॉट A/D। अब इस एयर फील्ड कैपेसिटर की जगह हम एक नया मटेरियल डाल दे रहे हैं, एक न्यू मीडियम डाल दे रहे हैं। इस मीडियम का न्यू मीडियम विच इज कंप्लीटली फिलिंग, completely fills the space। तो इस न्यू मीडियम का जो परमिटिविटी है वो एप्सिलॉन है। तो बच्चों, अगर आप कैपेसिटेंस के फॉर्मूले को, पैरेलल प्लेट कैपेसिटेंस के फॉर्मूले को रेफर करें तो आप पाते क्या है? कैपेसिटेंस डिपेंड्स अपॉन थ्री फैक्टर। फर्स्ट, द परमिटिविटी ऑफ द मीडियम, सेकंड, द एरिया ऑफ द प्लेट्स, एंड third, the distance between the two plates। So the new capacitance C dash will be permittivity of the new medium, that is epsilon A/D। What is epsilon? Epsilon over here is the permittivity of the medium, new medium that you are inserting in between the two plates। Now, from our basic definition, from our basic learning, relative permittivity of any medium is defined as the ratio of the permittivity of that medium when compared with the permittivity of air or vacuum. This we have studied in Coulomb's law. एप्सिलॉन क्या था? परमिटिविटी ऑफ द मीडियम. एप्सिलॉन नॉट क्या है? इसे हम कहते हैं एब्सोल्यूट परमिटिविटी. और ये एब्सोल्यूट परमिटिविटी क्या होती थी? एब्सोल्यूट परमिटिविटी होती है परमिटिविटी ऑफ एयर और वैक्यूम. एब्सोल्यूट परमिटिविटी इज permittivity of air or vacuum. इसी रिलेटिव परमिटिविटी को डाइलेक्ट्रिक कांस्टेंट भी कहते हैं. डाइलेक्ट्रिक कांस्टेंट, also known as dielectric constant, okay, denoted by symbol K. तो बच्चों ये चीज हम लोगों ने डिटेल में डिस्कस करी थी when we were talking about Coulomb's law. So if I take this thing into account, so I can say that epsilon upon epsilon naught, the ratio of permittivity of any medium when compared with the permittivity of free space or vacuum is referred as K, or the dielectric constant. Therefore, epsilon can be written as K times of epsilon naught. Hence, C dash is equals to epsilon की जगह we are replacing it by K epsilon naught into A by D, or C dash is equals to K epsilon naught A by D. If you see what is epsilon naught A by D, this is from the equation number 1, happens to be the capacitance of air filled capacitor. Therefore, I can say that C dash is equals to K times of C naught. So what you conclude? You got a conclusion over here that whenever the plates between the whenever the space between the two plates of the capacitor is filled by some sort of dielectric or with some sort of insulating medium apart from air, having dielectric constant as K, then the capacitance of such capacitor increases by a factor of K. So what I've said, I'm just writing it down over here. So if the space in between the two plates of capacitor, between the two plates of a capacitor is filled with some insulating medium other than air, then the new capacitance of the capacitor increases by K, by a factor of K times, by a factor of K or K times, where K is, what is K? Where K is the dielectric constant of the new medium, dielectric constant of the new medium. So you need to understand that whenever some medium is filled in between the two plates of the capacitor, the capacitance increases by a factor of K. Now, knowing this fact, let's try to understand what changes will occur on different other factors such as potential difference, charge stored, energy stored, electric field in between the two plates of the capacitor when this dielectric is going to get inserted. And we are going to discuss this factor on the basis of the fact whether the battery remains connected with the capacitor or whether you disconnect the battery and then you insert the dielectric. So we are going to discuss both the cases. Both the cases are very, very important for you all to understand, because on the basis of these factors we will be given different types of question in your board examination. Let's go ahead with that portion now. Now let's move further ahead now. What factors are going to vary when dielectric is going to get inserted? We learned that as soon as I insert the dielectric, the capacitance of the capacitors increases by K times. Now, whether the battery remains connected or whether the battery gets disconnected, there is no change on the capacitance. The capacitance is always going to increase K times. Now, there can be two aspects of asking this question. I can ask you, what factors are going to vary when battery remains कनेक्टेड? तो पहली चीज क्या होती है, दो तरीके से आप डाइलेक्ट्रिक को इंसर्ट कर सकते हैं. पहला तरीका क्या है कि बैटरी को आपने कनेक्टेड रहने दिया तब इंसर्ट किया डाइलेक्ट्रिक को, और दूसरा तरीका क्या है कि बैटरी को आपने डिस्कनेक्ट कर दिया, बैटरी इज disconnected and then dielectric is inserted, You will find number of questions coming from the council based on this concept. So battery remains connected and dielectric is inserted. And remember, presently we are talking about a dielectric which is going to completely occupy the space in between the two plates. So the first thing, battery remains connected and dielectric is inserted, and the second fact is, or the second way of inserting the dielectric is, battery is disconnected and then dielectric is inserted. No matter whatever you do, whether you let the battery be connected or whether you remove the battery and then insert the dielectric, the capacitance of the capacitor always increases by K times. So C dash is equals to K times of C naught. What is C naught? Where C naught is the capacitance, where C naught is the capacitance without dielectric, while C dash is the capacitance, after dielectric is inserted. So, and what is K? Where K is the dielectric constant of the medium inserted. K क्या है? Dielectric constant of the medium. Of the insulating medium. So no matter whether you remove the battery or whether you let the battery be connected, whenever the dielectric or insulating medium is inserted between the two plates, the capacitance of the capacitor is always going to increase by a factor of K. Is this point clear to everyone?
Yes, sir.
Okay, let's move on to the next part, the second part. If battery remains connected, तो अगर बैटरी को तुमने कनेक्ट रहने दिया तो बैटरी के कनेक्ट रहने से जो पोटेंशियल डिफरेंस है बिटवीन द टू प्लेट्स वो चेंज नहीं हो सकता, क्योंकि बैटरी कनेक्टेड, बैटरी का जॉब है पोटेंशियल डिफरेंस को मेंटेन रखना. तो अगर तुमने बैटरी को कनेक्टेड छोड़ा तो पोटेंशियल डिफरेंस अक्रॉस द प्लेट इज ऑलवेज गोइंग टू रिमेन द सेम. तो इफ बैटरी रिमेन्स कनेक्टेड तो क्या होगा? Potential difference across the plate is always going to remain same. Potential difference remains same. ये एक इंपॉर्टेंट फैक्टर है जो आपको ध्यान रखना है कि V डैश यानी पोटेंशियल आफ्टर द डाइलेक्ट्रिक एंड V potential before the dielectric is always going to remain the same. V dash will remain equal to V naught. What is V naught over here? V naught is the potential before the dielectric, potential difference before dielectric. Instead of potential difference, I'm writing down as PD, okay? Potential difference before dielectric, and this is V dash is potential difference after insertion of dielectric. Is that clear? Insertion of dielectric. तो यहां पर बच्चों क्या चीज नहीं चेंज होगी, यहां पर पोटेंशियल डिफरेंस चेंज नहीं होगा, जो पहले पोटेंशियल था वैसा ही का वैसा पोटेंशियल अभी भी बना रहेगा। तो अगर आपने बैटरी को कनेक्ट किया है तो सबसे इंपॉर्टेंट चीज जो आपको याद रखनी है कि इस केस में पोटेंशियल डिफरेंस रिमेन्स सेम। लेकिन अगर बैटरी रिमूव हो गई है जैसा कि इस केस में, तो पोटेंशियल तो अब सेम रहेगा नहीं भाई। यहाँ पे पोटेंशियल डिफरेंस कैन नॉट रिमेन सेम, पोटेंशियल डिफरेंस विल चेंज, पोटेंशियल डिफरेंस चेंजेस। बाकी डिटेल में आऊंगा, वहां पर पोटेंशियल डिफरेंस में चेंज तो कितना चेंज उसको अभी हम लोग समझें, ठीक है। अब अगर पोटेंशियल डिफरेंस यहां पर सेम रहा, कैपेसिटेंस बदल गया, तो यू हैव ऑलरेडी स्टडीड अ रिलेशनशिप। क्या रिलेशनशिप हम लोग पढ़ के आ रहे थे? सी डैश इज इक्वल्स सी इज इक्वल्स टू क्यू बाई वी। ये रिलेशन मालूम है ना?
Yes, sir.
This is what we know. As we know, this is the relationship is defined the capacitance of a capacitor. So Q is equals to CV. तो नया Q क्या हो गया? लेट्स से Q dash. Q dash will be equals to C dash V dash. What is Q dash? Q dash is the capacitance. Sorry, Q dash is the charge after the dielectric is inserted. C dash is what? C dash is the capacitance after the dielectric is inserted. V dash is the potential difference across the plates after the dielectric is inserted. So this is the Q dash, C dash and V dash. Now let's see what happens with Q dash. Q dash is equals to, क्या C dash वैसा ही है जैसा बिफोर था? क्या भी वही है? C dash की चेंज हो गया है C dash?
Sir, same.
नहीं बेटा, C dash तो बदल गया ना। बिफोर पहले कितना था? बिफोर द इंसर्शन ऑफ डाइलेक्ट्रिक इट वाज C नॉट, आफ्टर द इंसर्शन तो C तो चेंज हो गया। C dash की वैल्यू क्या हो गई है? K टाइम्स ऑफ C नॉट।
C naught.
और क्या V dash सेम है कि V dash बदला है प्रीवियस के कंपैरिजन में?
So V dash is same.
V dash
V dash is same.
so that is going to be equal to V naught. V dash is still equal to V naught. So what you find, Q dash is equals to K times of C naught V naught. What is C naught V naught? C naught V naught is nothing but the original charge. The Q dash is equals to K times of Q naught. So what you have learned, so by insertion of dielectrics in between the plates with the battery remains connected, the charge on the plates of the capacitor increases by a factor of K. Is this clear?
Yes, sir.
So what happens by the insertion of dielectrics, in between the plates of the capacitor with the battery remains connected, charge increases by K times. So what we learned up till now, if the battery remains connected and then you are inserting the dielectric, the capacitance increases by a factor of K. Since the potential, since the battery remains connected, so the potential difference across the plates of the dielectric is always going to remain the same. So potential difference remains the same. But what happens to the capacitance? The capacitance of the capacitor increases by a factor of K times. So This is the things that you should remember. Now the next factor that comes, is there any effect on the electric field in between the two plates of the capacitor? Now if you remember a relationship that we had studied in chapter of potential and potential difference, PD is equals to ED. Potential difference equals to E times D. So is the potential difference changing between the plates of the capacitor, bacha? Ask yourself, is this changing?
No, sir. Potential difference not changing.
Potential difference does not change. Is potential difference changing? Answer is no. Does the distance between the two plates of the capacitor changes?
No, sir.
That also remains the same. So can electric field change? Which, as potential difference is not changing, distance between the plates are not changing, so electric field is also not going to change. D also, distance between the two plates remains the same. D remains same. So E was equals to PD upon D. Since neither this has changed nor this has changed, so E dash is also going to be equal to E naught. Is this clear?
Yes, sir.
So whenever a dielectric is inserted in between the two plates of the capacitor with the battery remain connected, the electric field also does not changes. So this is another important aspect that you should understand. Let's move on to the last part for this, and that is, let's try to compare the energy. Do you all remember the formula for energy between the two plates of the capacitor? Energy between the plates of the capacitor is U is equals to half CV square, U is equals to half Q square by C, U is equals to half QV. Okay. Now I'm going to take this expression for the energy and I'm trying to discuss with you all on the basis of this. But energy between the two plates of the capacitor is given by the formula half CV square. So has C changed?
No, sir.
Yes, sir. Has C changed? पहले C क्या था? पहले C
Yes.
पहले
C
C
dash
पहले C
C naught था.
बाद में कितना हो गया? K times of C naught. तो C तो
K
बदल ही रहा है,
C naught.
irrespective of the fact बेटा कि हमने डाइलेक्ट्रिक बैटरी लगा कर डाली हो चाहे बैटरी हटा के डाली, कैपेसिटेंस हमेशा इंक्रीज करता है. याद रखना एज अ थंब रूल कि अगर आपने प्लेट्स के बीच में डाइलेक्ट्रिक को डाला तो कैपेसिटेंस ऑफ द कैपेसिटर विल ऑलवेज इंक्रीज बाय अ फैक्टर ऑफ के. तो कैपेसिटेंस हमेशा इंक्रीज करता है. हैज सी चेंज्ड? द आंसर विल ऑलवेज बी यस बाय अ फैक्टर ऑफ के. ओके, तो हाफ सी डैश कितना हो गया? नया सी क्या हो गया? के टाइम्स ऑफ सी नॉट. क्या पोटेंशियल डिफरेंस बिटवीन द टू प्लेट्स चेंज हुआ है?
No, sir.
Potential difference remains the same. So V is equals to V square. So if you see the new energy, let me call it as U dash, will be half K C naught V square, or U dash is equals to K times of half C naught V square. And what is half C naught V square? That was the original energy, K U naught. So what you are finding, by the insertion of the dielectric, the potential energy increases by a factor of K. So these are the factors which will vary on insertion of the dielectric. I believe you all must have taken a note of it. Let's move on to the next part. What factors will keep on changing if the battery is disconnected and then dielectric is inserted? Yes, Srishti.
So all the factors that you have mentioned is all are increasing by just K factor.
Here it's increasing by
all
K.
Of them.
Not all of them. Electric field has not changed. Potential has
changed.
not.
Or by key energy and the capacitance are increasing by K factor only.
Yeah, and charge also.
Okay, sir. Yes, sir.
Yeah. Let's move on to the next part. That is what factors is going to remain. What would happen if dielectric is inserted when the battery is disconnected, when you have removed the battery. Okay. So if you have removed the battery, and then you are inserting the dielectric in between the two plates of the capacitor. So any which ways, whether you are inserting the dielectric with the battery attached or without the battery attached, the capacitance will always increase by a factor of K. Now, if the battery is removed, what cannot change? Suppose there was a dielectric, or suppose there was a capacitor, and in that capacitor, what happened? You connected the battery. Then what is the role of battery? Battery is basically a pumping device. It pumps the charge. It starts pumping the charge to the capacitor, and capacitor now fills up. Is that clear?
Yes.
So once you have removed the battery, there is no other pumping device connected. So what is going to happen? The charge that is stored inside the capacitor is going to remain same or constant. So if the battery is disconnected and then you are allowing the dielectric to be inserted, what cannot change? Charge Q remains same. So Q dash is equals to Q naught. Why charge cannot increase now? Because no battery is there to further pump the charge. याद रखना बच्चों, बैटरी का रोल क्या है? बैटरी का रोल होता है चार्ज को पंप करना, एक पॉइंट से दूसरे पॉइंट तक भेजना. That is basically the role of a battery. It pumps the charge from one point to another, and the second job of the battery is to maintain a constant potential difference. अब आपने किया क्या? यहां पर इस केस में बैटरी को तो रिमूव कर दिया है, बैटरी को डिस्कनेक्ट कर दिया है. जब बैटरी ही डिस्कनेक्ट हो गई तो अब कोई डिवाइस ही नहीं है जो उस कैपेसिटर में चार्ज को पंप करके डाले. तो चार्ज को पंप करने वाली कोई चीज रही नहीं. तो जितना भी चार्ज उस कैपेसिटर के अंदर आ गया, रिमेंबर आई टोल्ड यू वेरी फर्स्ट डे, व्हाट इज अ कैपेसिटर? कैपेसिटर इज अ चार्ज स्टोरेज डिवाइस. एक टंकी है जो कि चार्ज को स्टोर करती है इन द फॉर्म ऑफ इलेक्ट्रोस्टैटिक पोटेंशियल एनर्जी. कैसे चार्ज को स्टोर करते हैं? इन द फॉर्म ऑफ इलेक्ट्रोस्टैटिक पोटेंशियल एनर्जी. और ये चार्ज को स्टोर कर रही है. चार्ज इसके अंदर जितना भी था आ गया, आपने बैटरी को रिमूव कर दिया. अब बैटरी रिमूव हो गया, कोई और डिवाइस है नहीं जो चार्ज को पंप करेगी, इसलिए चार्ज कैसा रहने वाला? चार्ज विल रिमेन कांस्टेंट. अगर चार्ज अब कांस्टेंट हो गया तो पोटेंशियल के ऊपर क्या फर्क आएगा? तुम्हें मालूम है, ये तुम जानते हो, V इज इक्वल्स टू Q बाई सी. पोटेंशियल का क्या फॉर्मूला हो जाएगा? V इज इक्वल्स टू Q बाई सी. अब जैसा क्वेश्चन देखो, अपने आप से पूछो, क्या चार्ज बदल रहा है इंसर्ट करने के बैटरी के? इज Q चेंजिंग?
No, sir. No, sir.
ओके गुड. सृष्टि, इज C चेंजिंग?
No, sir. C is also not changing.
अरे बच्चा, इंसर्ट करने पे डाइलेक्ट्रिक के तो
C changing.
C
C changing. C changing.
हाँ.
By K C naught.
सो V डैश Q ने चेंज नहीं किया, Q ही नॉट के बराबर है. C चेंज हो गया. C कितना हो गया? K टाइम्स ऑफ C नॉट.
K C naught.
तो V डैश क्या हो जाएगा? 1 अपॉन K Q नॉट बाई C नॉट. और अगर आप देखें तो V डैश इज इक्वल्स टू 1 बाई K टाइम्स ऑफ V नॉट. तो बाई इंसर्शन ऑफ डाइलेक्ट्रिक, व्हाट यू आर नोटिसिंग? Potential changes in this case. That is whenever the battery is disconnected. So if you are disconnecting the battery and then you are inserting the dielectric, the capacitor always increases, the capacitance always increases, charge remains constant, and potential now decreases by a factor of K. Is this clear?
Yes, sir.
Now let's refer to the second thing, or the next aspect of it. What effect will be taking place on potential electric field? Now you know potential difference is equals to E times of PD is equals to ED. Now, I'm looking forward to for the effect of electric field. E is equals to PD by D. अब जरा सोचो, क्या पोटेंशियल डिफरेंस में चेंज आया है?
Yes, sir. It decreases.
Decreases by a factor of K. Has this changed?
Okay.
Has
Yes,
the
sir.
distance between the plates changed? Has this changed?
No, sir.
So mu E dash PD ने बदल गया. PD कितना हो गया? नया PD क्या है? V dash क्या है? V naught by K. Distance अभी भी D है. V naught by K into D. V naught by D is your original PD. Sorry, original electric field. So E dash is equals to E naught by K. So what we learned that on insertion of dielectric, when the battery was removed, the electric field now gets reduced by a factor of K. I believe that is also clear to everyone. Is that okay? Shrishti, Hamad, Hanzala?
Yes, sir. Yes, sir. It is okay.
Okay. Now let's talk about energy. What would happen with the energy? Just now I told you three distinct formulas for the energy. U is equals to half CV square, U is equals to half Q square by C, isn't it? And then half QV. So these are the factors which we have already studied. Now let's try to understand and analyze what would happen to the potential energy stored inside the capacitor. So U is equals to half CV square. Answer the things. Has this changed?
Yes, sir. It is changed.
By what factor?
K.
K times of C naught. Very correct. Good, Shrishti. Now you have understood that it changes. And what happens with the potential difference? Has this changed?
It is decreased by a factor K.
Yes, has this changed? So you got a correct answer. V dash has now becomes V naught by K. So what would be the effect on U? U will be equals to half C dash, C की जगह के क्या आ गया? K times of C naught आ गया. And what has happened with potential difference? This has also changed and has now become V by K and this whole square, V naught by K whole square. So this will becomes now half K C naught, V naught square by K square. Now if you notice this K and this K goes off, so I get 1 by K into half C naught V naught square, and U, now U dash becomes 1 by K times of U naught, isn't it?
Yes, sir.
So what you learned in this case, potential energy decreases
decreases
by a factor of K.
factor K.
Very correct. So I believe you have understood the variation of different physical quantity on the insertion of dielectric, keeping two factors in our mind. What would happen to them when the battery remains connected? What would happen to them when the battery is removed? Is this clearly understood by all of you?
Yes, sir.
Let's move on to the next thing, and that is capacitance of a partially filled capacitor. So there is a capacitor whose capacitance is C naught. And this is presently having air inside. So there's a parallel plate capacitor C, whose capacitance is C naught. The capacitance of air filled capacitor. Up till now, when I was discussing, I was saying that the space between the two plates is completely filled with some sort of dielectric. Now what I am saying, it is partially filled. So I am inserting a dielectric. I am putting a dielectric in between the two plates, but this time this dielectric is not going to occupy the entire space between the two plates. Let's say originally the distance between them is d. So what happens when I am inserting a dielectric of thickness t in between the two plates? So this is a dielectric of dielectric constant K and of thickness T. So what is the thickness of this dielectric? The thickness of this dielectric is T. What is the dielectric constant of this? The dielectric constant of the material that you have inserted is K. Okay. As I just now told you, there is a capacitor of capacitance C naught with distance in between the two plates at D being the distance between the two plates, distance between the two plates. And what we are doing, we are inserting some dielectric of thickness T and dielectric constant K in between the two plates, and definitely the thickness of the dielectric is smaller than the distance between the two plates, so that it no longer completely occupy the space in between the two plates of the capacitor. If this is the situation, okay, if this is the situation, then what will be the new capacitance for such a capacitor? So dielectric does not completely occupies the space in between the two plates. Okay, so if this is happening, that then what will be the new capacitance? That what we are looking forward to find it out. Okay, so what I'm going to do, see, this dielectric of thickness T can be placed anywhere in between the two plates. What I'm going to do, I'm going to shift this dielectric very close to the left plate of the capacitor. So I'm going to make a new figure. Okay, and in this new figure, what I'm doing, I am going to bring this dielectric as close as possible to the left plate of the capacitor. Okay, that is what my concept is. What I'm going to do, I am going to bring this T thickness of dielectric and I'm going to place it as close as possible towards the left plate. So this is my left plate. What I am doing, I am placing this dielectric as closely as possible towards the left plate. Is that clear? Hello?
Yes, sir. Yes, sir. It is clear.
Okay, then what is happening? This dielectric has completely occupies this space, and I'm going to think about an imaginary surface like this towards the end of the dielectric. Okay, just for a second, we are just imagining an imaginary surface, and the right side of the plate is now going to be over here, isn't it? This much distance is T. What is this much distance now left?
D minus T.
This distance is now D minus T. Very correct, Shrishti. Vansh, are you there? Or you just came to check the connection?
Yes, sir.
I'm not getting any response from you, Vansh.
Sir, actually the network is not very good at my place.
Try to respond, yaar, if you are there. By responding only you will learn. Okay, any which ways. Let's move further ahead. So this distance, this is a dielectric and the thickness is T. So now can you see this as a one capacitor? Let's say this is my first capacitor C1, and since it is having a dielectric of K, and this imaginary line that I have drawn, just imagine is as a second plate of the dielectric, then I can say the capacitance of this dielectric to be K epsilon naught A upon what is the distance between the two plates, and that is T. This becomes my second capacitor C2, which is connected side by side with the first capacitor with the air as a dielectric in between, and the capacitance of this dielectric will be epsilon naught A upon D minus T. So what I have done, I've shifted the dielectric closer to the first place, and then I imagined an imaginary surface separating the two, separating the dielectric and the air medium. So this becomes my imaginary surface, which is separating the two, dielectric and air, imaginary surface. And then what I did, I considered this to be a dielectric filled, completely dielectric filled capacitor, whose capacitance is going to be given by the expression K epsilon naught A by T. What is T? T is the thickness of the dielectric. And then the second capacitor, which is kept side by side to the first capacitor with the air as a dielectric medium, and then it is going to be having a capacitance given by the expression epsilon naught A upon D minus T. So what I have done, I have found these two new capacitances for new two capacitors that have been formed. Is this much clear to you, Shrishti, as well as Vansh and others?
Yes.
So C2 is half partially filled and C1 is completely filled.
Yeah. See, this is completely filled with the dielectric. This is air filled. यहाँ पे अब कुछ नहीं है ना, तो यहाँ पर क्या रह गया? This is air filled.
Okay.
और यहाँ पे dielectric आ गया है, तो medium filled.
Yes, sir.
Is that clear, Shrishti?
Yes, sir.
As both the capacitors are arranged side by side, isn't it? As both the capacitors are arranged side by side, this can be thought as series combination of C1 and C2. Hence, net capacitance of this series combo can be found as, कैसे फाइंड कर सकते हैं? Can be found as, सीरीज कॉम्बिनेशन का फॉर्मूला क्या था? 1 upon CS is equals to 1 upon C1 plus 1 upon C2. Therefore 1 upon CS is equals to, what is 1 upon C1? 1 upon C1 is T upon K epsilon naught A. What is 1 upon C2? 1 upon C2 is nothing but D minus T upon epsilon naught A. Take epsilon naught A common. So what I'm going to have, T by K plus D minus T. Epsilon naught has been taken common from the denominator. So what is left in this? T by K plus D minus T. So the net capacitance, so this, let me call it as net capacitance now. So the net capacitance C net will be nothing but reciprocal of this, that is epsilon naught A upon T by K plus D minus T. So this is the net capacitance of a partially filled capacitor. This is the net capacitance of partially filled capacitor. Is this clear?
Yes, sir.
So this was all as far as the capacitor was concerned. Here we are going to end the capacitor topic.